We will going to learn about the library management system and all the requirement engineering model. So let's see about the library management system. So what are the formal requirement? What exactly we need from the library management system? So a library management system is a software which built to handle the primary housekeeping function of library. In a library management system to manage a set collection as well as relationship with their members. Library management system help libraries keep track of books and their checkouts as well as member subscription and profiles. Library management systems also involve maintaining the database for entering new articles and recording articles that have been borrowed with their respective due dates. So this is what we exactly do with library management system. So accordingly we can divide what exactly functional requirements, what exactly your system should do, and what are the extended functionality, like what is not necessarily my system should do. So that is called as a non-functional requirement. So functional requirement, my system must do all of these things. So these are, it should add article, it should update article, delete article, inquiry of the members. So inquiry of all current enrolled members, that should be if we want that detail should be displayed. Inquiry insurance, it should check out the article, it should have facility for check-in of the article or books or any kind of this journal or any kind of things. Inquiry waiting for approvals and reserve articles. Now the extended functionality that is not directly my LMS should do, that are the non-functional requirements, that is like safety requirement. So if your database may get crushed at any certain time due to virus or operating systems failure, so it is required to take the database backup. This is not necessarily we should do, but this is extended functionality that will also help your system. Security requirements, we're going to develop a secure database for the university. So there are different categories of user, namely teaching staff, administrator, library staff, students. So depending upon the category of user, access rights are decided. Software constraints, so the development of system will be constrained by the availability of required software such as database and development tools. The availability of these tools will be governed by your LMS. So there are different categories of non-functional requirements are also there. So these three categories are product requirement, organizational requirement, and external requirement. So product requirement are the requirements which specify that the delivered product must behave in a particular way. We want our whatever final output we are having, whatever software we have delivered, so what exactly it should behave. So that requirements will be your come under your product requirement. So such as example are your performance requirement, your execution speed, reliability, all this comes under your product requirement. Now, organizational requirements are the requirements which are consequence of organization policies and procedures. So there must be some kind of standard you must be using. So that process standards, what are the process standards you have used, what are the requirements for the implementation, that will come under your organizational requirements. And again, the third category of non-functional requirement is external requirement. Now there are some kind of requirements which arise from factors which are external to the system and its development process. So they are called as your external requirements. So examples of external requirements are interoperability requirement, legislative requirement, your safety security requirement, accounting requirement, and so on. Now we are at the LMS library management system. So we will divide that what is exactly functionality and what are the stakeholders. So functionality, like what is the thing my library management system will do. So it will obviously have all of this functionality like register user, add article, update, delete article, inquiry member, inquiry assurance, checkout article, check-in article, reserve article, search user permission, check account, prepare library database. And the people which are involved in creation and in the success of my library management system, that people could be your tester, your user, or your any, so they are called as a stakeholders. So what are the stakeholders? Like for the library management system are librarian, members of library management system, and the guest. So we will see requirement engineering, some of the requirement engineering models. So there are again five categories of requirement engineering models. First is scenario based model. How your the system, library management system, will be viewed from the user's point of view. So based on that, we draw different kinds of diagram. Again, in that we are having use case diagram. A use case diagram is a representation of a user interaction with the system. This interaction shows the relationship between the user and the different use cases in which the user is involved. Use cases is specifically kind of functionality your system will have. The purpose of use case diagram is to simply to provide a high level view of the system and convey the requirements in layman's terms for the stakeholders. So component of your use case diagram, like you are having different components while you draw the diagram, there is a system boundary, so which is represented by a kind of this shape, and this represent the scope of the system, all the actors which will lie outside of this square, and this is placed, all the use cases are placed inside the system boundary. Now these are the actors. Now an actor is an entity that interact directly with the system, but that is not the part of the system, so they could be called as actors. So your actor could be people, computer hardware, or other systems. Use cases. Use cases is generally represented by an oval kind of shape, and it represents a user goals and piece of functionality that can be achieved by accessing the system or software application. Now, if you want to show some kind of association, or there indicates a participation of the actor, like this actor will perform that kind of functionality, you will connect the that actor and that functionality by using some kind of arrow. So they are called as a association. So this is the association. Now next is generalization. Generalization relationship is used to represent the inheritance relationship between the model elements of the same type. Include, now if you are having two use cases, now include relationship is a relationship in which one use case include the functionality of another use case, and the include relationship supports a reuse of the functionality. Extends. The extend relationship specify that the incorporation of the extension use case is dependent on what happens when the base use case executes. And this is the constraint, like if you are having some condition, like if some condition show condition exists between the actors and the activity, then we write the condition on this arrow. So let's take example of extends and include. Now here we can see that we are having this two use cases, like what is the two functionality, login and checkout order status. So if I want to do this functionality, checkout order status, before that I should log in into the system, like this should be included before doing this activity. So that's why we say that for in any e-commerce application that provide customer with the option of checking status of their orders. Suppose I am purchasing anything, I have purchased anything on my Amazon, and to see the status of the order, I should first of all log in into that account. So this is there, so that's why we say that this is included, like if this will happen, then and then only we can go for it. And the next relationship is your extend. Now you can go for pay for item, like if you're going for purchasing anything, so you want to pay on e-commerce site, so this could be further divided, like you can pay the items by using pay by card, pay on delivery, cash on delivery, and so on. So this is the thing you could do for the paying of the atoms. Again, you are having multiple options for that particular thing. So this is extended, like they will be performed if if this thing will be get executed. So the guidelines for constructing use case diagram is determine the system boundary, ensure that actors are focused. Each actor should have a single coherent purpose. If a real world object contains a multiple purpose, capture them with separate actor. Each use case must provide value of users. Relate use case and actor. So we'll go for drawing your use case. First of all, we'll find out what are the stakeholders and what are the functionality. We will separate them out. So there are three stakeholders: librarian, guest, and member. Librarian will have the access to your register, add, update, delete articles, check in articles, check out articles. It will have access to inquiry members, inquiry assurance, and set user permission. Now guest can request for the registration, and the members of library can reserve the article, search article, and check account. So we'll draw the use case diagram. First of all, to draw the use case diagram, we need to draw some kind of boundary that this is my system, that this is the system boundary, and my whole system will lie inside this. So what are the functionality of the system? So these are some kind of functionality I'm having in this system. Now if you want to search article, again, now this is like extended, here we have used extended relation. If you want to search the article, again, in that search article, you can search the article by using title or by using publication. So that's why we have connected this kind of functionality by using extend. So these are the part of this functionality. Now this is executed only when like this thing is executed. And the external stakeholders are the actors. Now these are the actors: librarian, guest, and members. Now what are the functionality will be what are the functionality will be done by the librarian? So we should connect that functionality with the librarian by using this association or arrow. So these are the functionality which will be conducted or done by this librarian, and these are the functionality which are done by guest, and this is the functionality which have the access to the members. So this is the use case diagram. Now the usage scenario, a collection of user scenarios that describe the trade-off uses of the system. Now each scenario is described from the point of view of an actor. An actor is a person or a device that interact with the software. So what we will have in this scenario, each scenario answers the following question. So who is the primary actor and secondary actor? What is the actor's goal? What precondition should exist before the story begins? Now your user scenario kind of story, where you are just providing when you want to perform any functionality, what kind of things you will do. So who will be this actor and who will be the second actor? What is the goal? All these things you will add in into that particular story. So what main task or function are performed by the actor? What extension might be considered as the story is described? What variations in the actor interaction are possible? So all these things are described by your usage scenario. So let's take example of usage scenario. Before that, scenarios are created by user researchers to help communicate with the design team, and user stories are created by project or product managers to define requirements prior to sprint in agile development. So scenarios are stories that capture the goals, motivation, and task of persona in a given system. User stories provide a rapid way of handling customer requirements instead of formal requirement document. So let's see the story or usage scenario for your the login. So feature is the login. Now again, in that login, what will be the scenario? Like scenario will be story will be if your user login with valid username and password. This is the story. So how this will be get accomplished? So prerequisite for this is that your user must have a proper client installed or user terminal. So you should have that kind of facility. Then your story begins. What will happen when user login with a valid username and password? So given that user navigates to the login screen, then user enter the correct name, username, correct password, then click on the login button. System verifies this user information and display the dashboard of user. So whatever dashboard you are having for the user, that will be get displayed along with the username on the top right side. So and there could be a logout button. So this happens when you perform successful login. Now if you get failed, so that will be the another story for that usage scenario. Like usage scenario will be your user login with invalid username and password. So what will happen? So if you navigated to login screen, you have entered the wrong username and wrong password, and you have clicked on the login button. So system will verify the information and it will print some error message that there is a kind of invalid login details for the username and password. you will not get into that account. So this is your user scenarios and stories. Now we'll move to the next diagram, that is activity diagram. So now it's okay that we know that functionality are there in broader views, are what are the functionality are there. So what kind of activity that user will perform. So an activity diagram is visually presents a series of operation or flow of control in a system similar to algorithm or flow chart. So this consists of flow of your activities. An activity diagram is like a traditional flow chart in that it shows the flow of control from one step to other. An activity diagram can show both sequential concurrent flow of control, and mainly it focuses on sequence of operation rather than object. So what are the operation you will going to perform rather than what are the objects you are having in that system. So that is the mainly focus, and it is usually represent the dynamic behavior of the system, and it shows how my system will work. So it is the most useful during the early stages of designing algorithm and workflows. So it helps in finding out the algorithm. So activity, the main element of what are the elements of the activity diagram. So this is the activity, in that you will write the what is the functionality which is performed by the system. Now next is your branches. So if you're having some condition, or if you want to take some decision, in that case you use these branches. So that branches could lead to true or false, or there could be based on success or failure depending on what is the output of that condition. Now initiation. So for the starting point, we use this kind of solid circle, and that is extended with the arrow, and then all this activity diagram gets started with the further activity. Now if you want to terminate your diagram, if you want to show that there is the end of that activity diagram, you use the bull's eye symbol like this. So which is a solid circle surrounded by a hollow circle. It has only incoming arrow. We never have the outgoing arrow for this termination symbol, which shows the end of your activity diagram. And if you want to denote that there is a concurrent activities are there, so if two activities are getting merged into one activity, you use this symbol. And if one activity is getting divided into more than one activity, there is no condition, but still that is getting divided into multiple activities, so we use this fork symbol. So let's take the example of a fork and join. So an example of business flow activity of order processing. Based on example, order is input parameter of the activity. After order is accepted, so like your received order, so all the required information is filled in. Payment is accepted, order is shipped. So you will fill the order, you will send invoice, and if you are filling the order, again in that you will have the kind of what is the category of order, so whether it's a special delivery or regular delivery. So this is the thing you will choose. There could be a decision for this, and all this will come and do this, all this will lead to the final thing, that will be the close order. So what are the guidelines for the activity diagram? So activity diagram elaborate the details of computation, thus documenting the steps needed to implement an operation or business process. An activity diagram can help developers to understand complex computations by graphically displaying the progression through intermediate execution step. Here is some advice for activity diagram. Don't misuse activity diagram. Activity diagram are intended to elaborate use case and sequence. For that, we are using this activity diagram model so that a developer can study algorithm and workflow. Activity diagrams supplement the object-oriented focus of UML models and should not be used as an excuse to develop software via flowchart. Level diagrams. Activities on a diagram should be at a consistent level of details. Place additional details for an activity in a separate diagram. Be careful with the branches and conditions. If there are conditions, at least one must be satisfied when an activity completes. Consider using an else condition. It is possible for multiple conditions to be satisfied, otherwise this is an error condition. Be careful with concurrent activities, means that the activities can complete in any order and still yield an acceptable result. Before a merge can happen, all input must first complete. So how to draw an activity diagram? We will follow the steps. Step will be identify the various activities and actions your business process or system will require. Find the flow among activities. For example, in a library management system, book issue is a one business process or a function. So we prepare a activity diagram for book issue. So various activity in book issue process like check availability of book, validate the member, check number of book issue by member, add book issue details to transaction, update number of book issue by member, update book status. So we will take for this one functionality, we will take the activity diagram. So we'll take for the functionality is our book issue. So now this my diagram is started. Now the first thing I will go for the book issue is I will check the availability of book. Then and then only I can issue the book to the user. Now again in that condition is that if book is available you can proceed for book issue. If book is not available, what you will do, you will alert book is not available and you will stop there. You cannot issue the book to the user. Now if book is available, you will validate the member and then you will add that details of book into the user's account. Then again you will check if that is authorized user or unauthorized user. If that is an unauthorized user, you will alert not a valid member, you will stop there. If that is authorized member who is a kind of member to that particular library, the number of book issued to the member, you will check that if it is exceeding the maximum limit, so again you cannot issue the book. You will give the alert that no more books can be issued if it is still having some count of that books are still less in his or her account. Like if you can issue only 10 books to per user, so if he or she has issued only 8 books, then and then only you can issue the book. So you can add the book issue details to transaction. Again, when you will add the book issue transaction simultaneously, you will do these two things. Like you will update number of book issued to the member. So now if 8 books were issued to the user, now after adding this one book, that will become 9 book. 9 books are issued to the members. Like you will update number of book issue, and at the same time you will update the book status. Like for the library purpose, you will update that that book is already issued to someone, and then you will stop there. So this is the thing will happen in your activity diagram for one functionality, that is the book issue. Now to extend this activity diagram, here we are not able to understand like who is doing this activity, whether that is like the thing is done by the librarian or what kind of stakeholders are doing this activity. Now we want to elaborate this activity diagram with the purpose of stakeholders who are the actors. So we will go for the swim lane diagram. So in a business model, it is often useful to know which human department is responsible for an activity. So when design of the system is complete, the activity will be assigned to a person or department, but at a high level it is sufficient to partition the activities among department. You can show such partitioning with an activity diagram by dividing into columns and lines. So each column is a called swim lane by analogy to a swimming pool. Placing an activity within a particular swim lane indicates that is performed by a person or department. So line across swim lane boundaries indicate interaction among different person or department. So like what is the swim lane? Like this is a swim lane for the librarian, and what are the activities which are performed between these two actors? Like this another actor is library management system. So what are the activity which are performed? That could be shown by this. So how we will proceed for this swim lane diagram? So to draw swim lane diagram, we should follow the steps. That first step should be identify what are the various activities and what are the various action your business process or system will follow. Obviously whatever activity diagram you will for whatever activity diagram you did all these things, you just need out to figure out all of these things. So just second step will be figure out which person department or department are responsible for completion of that activity, and figure out in which order the action are processed. Next thing is that we have to figure out who is responsible for each action and assign them a swim lane, and group each action they're responsible for under them. So again for the book issue, there could be only the two things we will need, that is we will need only librarian and library management system. We are just dividing this activity diagram. We are just changing the shape of our activity diagram in such a way that we could understand that this thing is done by the librarian and this thing is done by your library management system. So first of all, librarian will check the availability of the book. Then if the book is available, if a book is not available, it will give the alert book is not available, and he will stop the library management system will give the alert that book is not available and will stop. If book is available, library management system will hand over it to the librarian, and he or she can validate the members. So next thing is that while validating the members, again librarian could give it will allow the library LMS to see whether that user is authorized user or unauthorized user. So if user is not authorized user, so it will give the LMS, like your library management system itself will give the alert that that is not a valid member. If that is authorized member, it will give control to the librarian, so that he or she can issue the book. So this process follows like the same thing which we have used now, but here clearly we can understand like what is the portion which is done by, or what are the activities which are done by my librarian, and what are the activities which are done by my library management system. So at the end, your library management system will be ended by using this symbol, bullseye symbol. So these are the some kind of things we will use in scenario based diagram. From the user's point of view, what are the things you will perform? So these are the three diagrams: use case diagram, activity diagram, and Swimlane diagram. Now next category is class based model, where you are just representing your whole system as per the object oriented point of view concern. So the purpose of class modeling is to describe objects in the system and different types of relationship between them. So it is used to construct and visualize object oriented system. Class modeling is used to specify the structure of the object classes components that exist in the problem domain or system. Class diagram provides a graphic notation for modeling classes and their relationship. So it is act as a blueprint of an object. Your class is a blueprint of an object. So an object is a concept, abstraction, or thing which with an identity that has meaning for an application. So why we draw this class diagram? Because we want to represent overview of system in terms of object oriented system. So whatever things we are having in object oriented system, that could be included over here. So they are such as like classes, attributes, operations, and relationship. So the elements of class diagram are your class name, attributes, and operations. So class name is a name of class appears at the upper section. It has some meaningful name, and it is always aligned to the center of the upper section. Your class name is always start with your capital letters, and intermediate letter is a capital, and your class name should always be in a bold format. So these are the examples, and in suppose if you are having some kind of abstract class, in the class in which the functions are not you are not having code for the function. So for that class you will write that name of the class in the italic format. And if you are having normal class, so you will write the simple name without any italic format. Now next thing is that, for example, my banking system, there are two types of accounts. One is saving account and another is my current account. We are not taking LMS. We are just taking the banking system ka example. So account is an abstract class, and saving account and current account is a subclass of an account. So system can't directly access the account class. Here we cannot access the account. So again, account will be of two types, saving account and current account. So as this is my abstract class, I will use italic format for this. And now these are not the these are just the simple classes. So we will use this format for these classes. Another thing is attributes. Your attribute is a name, a property of a class that describe the value for each and every value held by each object of the class. Is the second component of your class box, and the attribute name should be in a irregular face, left a line in a box and use the lowercase letter for the first character. The data type for the attribute should be written after the colon. Accessibility of attribute must be defined using a member access modifier. So for example, your what is the format for writing your attributes? So you will write that by using access modifier. So what is the access, whether that is public, private, protected? So for that we are having some special symbols. We will use that access modifier, the name of the attribute, colon, the data type of that attribute, and suppose if you are initializing that with some default value, so equal to what that default value is. So again we will see what are the different access modifiers you will have for this particular attribute. Suppose your attribute is public attribute, which is that attribute will be accessed by all other classes. You will use plus symbol. uh, if your attribute is private attribute, you will use minus symbol, which cannot be accessed outside of your class. If your attribute is protected, like the attribute which is accessed only by its subclasses, if you're using some kind of inheritance, only its subclass will use that attribute. So for that thing you will use this hash symbol. If you're using a package member, then the package is represented by using the tilde symbol, where that all the classes within that particular package will use that particular attribute, and within the same package you will use that attribute. And if you're having some kind of static attribute, so you will underline that particular attribute. So you will not use the access modifier before that. You will just underline whole that name. And the last thing is that operation. Operation in the classes are a function or procedures that may be applied to the object in the class. It's a third component of your class box. So the how we write this operation, we write the access modifier, the method name or operation name, and the argument list, and at the colon at the end we write the return type for that particular operation. So for example, the same access modifier will be used for the our operations. Now this is a public kind of operation, so here we will use plus. The name of operation is change phone number. For changing phone number, what are the arguments you will need? That is a phone number which is of type string, and now this function or this operation is of type it will return integer value, so that's why we will write colon int after it. So again we are having generalization and specialization. Generalization is the process of extracting shared characteristics from two or more classes and combining them into generalized superclasses. Now if you're using some kind of inheritance or some kind of thing, so here vehicle could be divided into car and truck. So here you will use this kind of symbol. So this is called as a generalization. And if you are specifying that into different kinds of things, so we could say that we are using some kind of inheritance, so we could use this, like we could say that this is a specialization, and exactly opposite reverse process of your specialization is generalization. So for the account also we can say that the generalization is your this thing. You can more generalizedly say that saving account is a type of account and current account is a type of account. So this flow will be your generalization, and the opposite flow, like account could be of two types, saving account and current account. So this is my specialization. So there are different kinds of things are there in your class diagram. You are having some links and association for establishing relationship among object and classes. You are having aggregations and composition. Aggregation is a subset of association. It is a collection of different things. It is more specific than an association. It represents has a relationship. So suppose we can say here we are considering a car and a wheel example. So a car cannot move without a wheel, and but the wheel can be independently used with a bike or scooter or cycle or any other vehicle. So we can say that wheel object can exist without car object, but proves to be an aggregation relationship. So we can say that for execution of car, we must have car should be aligned with the wheel, or car should have a wheel. So that's why we are writing this kind of things, and this is a kind of aggregation where we can say that Okay, will could be independently used with any kind of vehicle, that could be your cycle, scooter, anything. So here this is a kind of aggregation which proves that their wheel object can exist without car objects. So it's a aggregation relationship, and the composition is part of aggregation. It represents a dependency between the parent and its children, which means if parent is discarded, then its children will be discarded. So it is a part of relation. So we can say a person will have the brain, have heart and legs, all these organs, a person class with the brain class. So if a person is destroyed, okay, if this is destroyed, all this thing will be get destroyed. This whole thing, these are the things which could act independently. We could have brains and all that, but we should need, for functioning of this particular organ, we should have a person, otherwise they will not function. So this is the thing. So for that we use this composition symbol, a diamond filled with a filled diamond, and this is your aggregation. Now here this wheel could class wheel can independently used with the bike, scooter or any other vehicle. So that's why you use this. The car is fully dependent on the wheel, but wheel is not dependent on this. But here we can say that your this person is your brain is fully dependent, like person is if person is destroyed, this thing will not have any meaning. Multiplicity. So multiplicity is the thing where we can specify, is the specification of number of instances of one class that may be related to instance of another class. Like we can say how many number of related objects are there. So there are different kinds of cardinality. There could be 0 to 1, no instances, or no or one instance. We are having exactly one instance. We are having 0 or more instances of that particular thing. We are having one or more instance, exactly 5 instance, at least m but not more than n instances. So this denotes your multiplicity. So we can say that, for example, your account holder, one account holder has only one unique checkbook, so that's why we written 1 1 over here. So one account holder can have can issue at the most one debit card. So here we can have like 0 or 1 debit card. So account holder can have multiple types of can have multiple number of debit cards, but that could strictly end at the count of one. So that's why we written star over here and 0 and 1 over here, because we are again having option over here. That's why we written start over here. Many to many association, one account holder can have many ATMs, so that's why we are written star over here. A bank, one bank can have multiple branches, but the bank should have at least one branch. So this is the kind of things we are having for your bank management system. So this is a class diagram where we are representing some kind of aggregation, some kind of now this is generalization and specification. Now here again we are using this kind of membership function, multiplicity, and now here all of these attributes are having some kind of access specifiers. Now this is the function for each of these classes. Now this is my abstract class. So whole this is the diagram for your bank management system, and this is the diagram for your library management system. So here we are using compositions. This is a kind of generalization and specification, and this is thing we are having in our whole of this library management system. Again, this is abstract class. This will be material will be further divided into your book, question paper and CD DVD. That's why we written this class in the italic format. So this is a kind of multiplicity. One librarian can manage, at least it could manage one member, one or more member, but at least at a time it could manage one member. So this is the thing we are using for the library management system. Now next thing is that how we will represent the behavior of our system. So for that we are using different kinds of diagram. So your first diagram is your state diagram. It is a graph whose node are states and whose directed arcs are the transition between the states. A state describes a specific state sequence caused by an event. Suppose if you're performing any kind of things and events are happening, so in that we will to denote transition between any events, we use this state diagram. So for example, if all objects, if we are using for state diagram, we can say that this is the example of your state diagram. Here for one particular important object, for one object we draw the state diagram. So there are there are different things in which you can draw the state diagram also, but here we are drawing the state diagram for one object. So from one state to other state, how this state is getting changed from one thing, one state to other state for this particular object. So these are the states, and what thing is allowing this state to get changed. So this is denoted by using arrow labeled with that particular functionality, the thing which is uh, allowing me to change this state. So this is the thing we use in the state diagram. So we can say that what are the things we are having in the state diagram. So the initial state is represented by using solid circle with the outgoing edge, and to denote the final state we use this bull's eye symbol, or we use this termination symbol. Now every state is represented by using a rounded box containing name of the state, and to denote the transition we write what is the event which is happening on that particular state, what was happened so that the state was changed or condition. So we write that into this particular format. Again we are having, so how we can draw the state diagram. First of all, we need to identify what are the important objects are there for which we need to draw the state diagram. Then we have to identify what are the possible states we will have in that particular objects. Suppose you are having the object as book, so your book could be issued, your book is available. So there are lots of things are what are lots of states are available for one single object, that is a book. Then identify the initial state and the final termination state. Label event which triggers this termination. Now first thing is that for drawing state diagram for library management system, we need to identify what are the different important objects are available. So we are having books, CDs, newspaper, library and member. Then identify state of one particular object. Suppose we want to draw a state diagram for the book. So for book, what are the states will be there? Your book could be available, it could be issued, it could we could return the book, we could renew the book. So these four kind of states will be available for book object. Now what are the things which convert these states into different states? So we need to identify the event or transition. So book issued to users, submit the book, request to issue same book, completion of exam or end of the semester. All this could change your state of this book objects. So this is the diagram for book. Now to draw the state diagram for one object, we use this kind of symbol where we are at the leftmost corner, leftmost top right corner, left topmost corner, we are using name of the object. So here my diagram is started. This is the first state of my object book that is available. If your book is available, we can issue it to the user. Now the state will change, that is issue. If the book is issued, the user could request to issue the same book, we could renew the book. If book is renewed, we could book a reissue to this particular state. Now again, if the exam is completed, or number of days of the book for that particular book is completed, or user want to return the book, he could return the book, and he could submit the book to the librarian, so that again the book will be available to all other users. So these are the states for one particular book. So in the same way, the state diagram for the bank automated teller machine, that is ATM, will be these things like we could have different things for the ATMs. Your ATM will have your bank ATM initially it could be off. Then we need to start up the bank ATM. After you will start up the bank ATM, it could be get in the self test mode. It if successfully, it will be in this self test mode, it will go to the idle state. If failure will happen, it will go into the out of service. So this thing will go to the bank ATM. These are the states for the bank ATM. If they need a service, so it could go in the maintenance state. Again, we will restart, and so that it will go in the self test mode. So this is the thing. If that is in the idle state, we can insert the card into the bank ATM. Then it could serve the customer. So again, while serving the customer, we could have the different things for the that particular bank ATM. Like it could perform customer authentication, then selecting transaction, performing that transaction, and ending that transaction. Then after completion of this whole thing, like suppose any user wants to take out some money from that bank, from the ATM, so it could perform all of this thing. Then it will he or she will remove the card. Again, your bank ATM will be get converted into the idle state. So again, let's take another diagram for the online order. So this is the diagram for the online order. So here, initially your order could be in the unprocessed. When you will receive the order, it could be in unprocessed state. If you are receiving the order, you check that order, you will accept that order. Then if you are rejecting that order, so it could be get into the rejected mode. So if that accepted order is if your items are available, once you accept that order for the online order, you will fulfill that order. And if the items are not available, your items are you will get the items, and you will try to fulfill that particular order, because you have accepted that order. So at the end, you will have the end to this particular object, that is your order. So these are some of the example for your state diagram. Here we have drawn the diagrams for each and every object. Now the next diagram is sequence diagram. Now we have drawn the diagram for each and every object, where we have denoted what are the states which will be available for each and every object. So how this transition will be happen. But now we want to show the participants in an interaction and the sequence of message among them. So we could say, we want to show that there are some of the examples. Each and every use cases, and a sequence diagram represent dynamic communication between objects during execution of task. Like if you are taking the object, like if you are performing any order, online order, so what are the things will happen between any two orders, any two particular actors, that will be represented by your sequence diagram. Now the objects are getting happen at the, so execution, how this will be get executed. Now each use case requires one or more sequence diagram to describe its behavior. For each and every use cases, for each and every functionality, we draw the sequence diagram. And in sequence diagram, along with the actors, we perform how that actor will interact with the system. So what are the things are there for that particular actors, so how that particular functionality is getting done by that particular actor. So that is drawn by using your sequence diagram. So it is based to show a specific portion of use case, not attempt to be too general. So what are the components of the sequence diagram you are having? First is your object class roles or participants that are drawn by using this. What is the object and what is the class of that particular object? Your activation or execution occurrence. So that will be denoted by using this symbol, where you could have your activation boxes represent time an object needs to complete a task, where you will wait for a reply message. And lifeline, represent object is an interaction, object in an interaction. So this object could be in the interaction, so this could be in the waiting state or this could be in any state. So that is the lifeline for that object. And the messages will be shown by this arrow along with the name of along with the name for that particular message. So if you are having synchronous or asynchronous message, you will draw the arrows. If you are having reply, if you want to give the reply message, that will be drawn by using dashed arrow. If you want to delete the message, you will write the arrow, and at the end you will write the X symbol. So here X denotes the end of your diagram. So if you want to again delete the message, you will write the X at the end of your solid line. So what are the guidelines for the sequence diagram? So we must prepare at least one scenario per use case. The steps in the scenario should be logical commands, not individual buttons. And we should write a scenario for each of this, and abstract the scenarios into sequence diagram, divide the complete interaction, and prepare the sequence diagram for each error condition. The steps to draw a sequence diagram are: first step will be select one scenario, then identify necessary set of objects who is taking part into that particular scenario, identify necessary interaction, and describe the message exchange between the object, then identify sequence of interaction and who starts the interaction. So for example, sequence diagram for book issue. Now this is the thing, this is the thing for this book issue. For this kind of use cases or functionality, one business process or function in this is a kind of one functionality in the library management system. So necessary objects for book issue will be what are the things which are there which are needed for the book issue. We should have library and book member and transactions, and member class object starts the interaction. So various interaction in the book issue processes. So what are the things, how we can interact for the one book issue? So we could request for a book, check availability of book, validate the member, check number of book issued by the member, add book issue details to transaction. So but here we are not able to understand who is initiating that particular process. Now this functionality is done by which particular user. So what are the message, what is the interaction is happening between all of these objects? So to understand that, we are drawing sequence diagram for the book issue. So these are my objects: librarian, book, and member. This is the lifeline for these objects. Now first thing is that member will request for a book. Now this is the thing like where we are performing any kind of communication. This message, this activity, this message will be given to the librarian. Again, now librarian will now here immediately librarian could not give the reply to the member, so it will first of all check the availability of book. Now this kind of interaction is getting done by in between the librarian and book. Now book, now if the book is available, now the reply will be given, yes, book is available in the rack number is so so. Now based on that reply, librarian will validate the member. So if again so based on the validated that member's account, so you could get response from the for the validation from the member. So librarian could check the number of book issued. So the members, from the members account, you could see the what are the books can be issued or not. So whether its maximum limit is ended or not. So you can issue the books. So you will get the reply from this members account. You will update the book status, and simultaneously you will update the member status. So as this completes your book issue steps, at the end you will end the lifeline of this. So this is the end of your book issue diagram, and this is the sequence diagram. Here these are your objects, and this is the message which is getting interaction. This is a kind of interaction which is happening between all of these objects.